when performing operations with radicals, the process to simplify through addition, subtraction, multiplication, and division is very similar to how we work with variable expressions. So to show each of these examples, I'm going to show you first an example from algebra that you already know. So let's take a look at this first example here. So the rule in algebra when you're adding and subtracting algebraic terms is that you can only simplify when the variable term is exactly the same. That's the key. If so, then you add or subtract the coefficients. So in actually all three of these examples, let's take a look at how that works. In the first one, we have to add 5x to 3y. Because the variable term has to be exactly the same, this cannot be simplified because the 5x and the 3y have different variable terms. And so this is where I would leave it at my final answer. In the second problem, however, I can combine some of the terms. The 3x and the 2x are both terms that have the variable x in them. So this term and this term can be added together. The 4y, because it contains a y, cannot be combined, and so this ends up being 5x because, again, it says you, if so, add or subtract the coefficients, which I'm adding those coefficients 3 and 2. So our simplified answer would be 5x minus 4y. Last but not least, in the problem here at the bottom, we actually have two sets of like terms. We have our 3x and our 6x, or I should say negative 6x. Be careful with that. And I also have my negative 4y and my positive 5y. So I can combine these terms together. The x's, 3x and minus 6x, when I add the coefficients together, I get negative 3x. When I add the coefficients of the y's together, that's negative 4 and positive 5, that's going to give me a positive 1y, or you could just have called it y. Negative 3x plus y is another way to saying that. So using this idea now, we can apply it to working with radicals. The rules for radicals is that you can only simplify when the radicand and the root are the same. Now in all of these examples, our root is going to be 2 for everything. We're dealing with square roots here. You'll learn more about the different roots in a later course. But if the radicand's kind of like the variable, radicand, remember, is the number inside of the square root. If it is same, if so, you add or subtract the coefficients. Very similar. In the first one, we have a radicand of 2. That's the number inside the radical, and a radicand of 3. Because those radicands, or numbers inside the radicals, are not the same, I cannot simplify it. And so my answer would just simply be left as 5 root 2 plus 3 root 3. Kind of similar to what we did over here. Going to this example, kind of like we look at example 2, so these are parallel to each other. The 3 root 3 and the 2 root 3 can be combined because they both have a radicand of a 3. So I can add these two together by adding their coefficients together, just like we did with the algebra example, which means this is going to be 5 root 3. Now the 4 root 2, because it had a different radicand, cannot be combined. And so this would be our final answer here. Move into the last example. We have a 7. We have a 7 as a radicand. And we also have a root 2 and a root 2. So just like we've done before, we're going to be able to add those like terms by combining their coefficients together. 3 and negative 6 will give me negative 3 root 7, so I'd leave the radicand be, just like I did with the variables. And negative 4 root 2 plus 5 is positive 1 root 2, or just square root of 2. Here's an example I want you to be careful of. When looking at this problem, the square root of 8 plus the square root of 2, without really looking too deep into it, you may say to yourself, you know what? The radicand is 8, the radicand is 2. I can't combine these terms together. But what you must keep in mind is when you're combining radicals that you should always combine them as simplified radicals. See the previous video on this lesson to talk about simplifying radicals. The square root of 8 can be simplified. Remember that it can break down as 4 times 2, and the 4 breaks down as 2 times 2. Because I have a perfect square of 2 times 2 here, I can move that to the outside. This problem is actually going to be rewritten as 2 root 2 plus the square root of 2. And so even though from the naked eye, you don't see that you can add them together, It's actually true that you can, because the square root of 8 simplifies to a radicand of 2, and since this is also 2, these are going to combine. Like in algebra, if there's no number in front of the radical, it's assumed to be a 1. So 2 plus 1 would give me 3 root 2 as my simplified answer. Now we're going to take a look at the second half of this. Now we're going to look at multiplication and division. So first, let's use algebra as an example to review. When you multiply and divide in algebra, you're going to multiply and divide your coefficients with each other, and you're going to multiply and divide your variables with each other. So you're going to combine coefficients with coefficients and variables with variables. So in the first one, we're going to combine the 5 and the 5 by multiplication. Those are our coefficients or our numbers. 5 times 5 is 25. X times y, well, we can't combine that, so we would just simply write it as xy. Looking at the second example, we would combine 3 with the 2 through multiplication, which is going to give me 6. X times x, which is actually going to be x squared, and I still have my 4y in the denominator. Now, the x squared and the y can't be divided amongst each other, but the 6 and the 4 can certainly be simplified. There's going to be a common factor of 2 there, and so this is going to divide out. When you divide that 2 out, you're going to get 3x squared over 2y as your final answer. And last but not least here in this problem, when you're multiplying here, kind of like the first example, the 5 and the 6 will multiply to give you 30. The x and the y will combine to give you just xy. So the idea here to take away from the algebra is coefficients can only go with coefficients and variables can only go with variables. That exact same principle is applied to the land of radicals. So now we move our minds to radicals and say this. To when you're multiplying and dividing radicals, coefficients will multiply with each other and radicands will multiply with each other. So coefficients can only go with coefficients, radicands I should say, go with radicands. So in the first example, I'm going to take 5 and the 5 because they are coefficients and write 25. And then the radicand of 2 and the radicand of 3 can be combined, and we're going to say that's square root of 6. So 25 root 6 is our final answer. Again, the root 6 can't be simplified. Moving to the next example, once again, we're going to multiply the numerators together first. 3 times 2 is going to give me 6. 3 times 3 is going to give me the square root of 9. We do know that. We're going to talk about that in a moment. And the bottom I get 4 root 2. Now, if you do end up with something you can simplify, you should simplify it. So that means this is going to become 6 times 3 over 4 root 2. Now, some of you may say, well, I can get rid of the 6 and the 4 because they have a common factor of 2. You can certainly do that. You can do it right here at this step, or you can wait till you multiply the 6 and the 3 together. I'm going to wait a moment, and we're going to get 18 over 4 root 2. And now we can go ahead and take that factor of 2 out. So when I do that, this is going to become 9, this is going to become 2, and so our final answer, and I'm a little bit out of space, so I'm going to draw an arrow up here, would be 9 over 2 square root of 2. Now, in the previous video, there was a mention that you cannot have a radical in the denominator. So this, while you may say, hey, it's multiplied together, is not truly simplified. If you aren't sure what to do with that, see the previous video. But basically what you're going to do is, and I'm going to write at the bottom of this page, is I'm going to multiply top and bottom by that square root of 2 to get rid of it. So when I do that, my numerator ends up being 9 square root of 2. My denominator will then become 2 times the square root of 4, which 2 times the square root of 4 is 2, and 2 times 2 is 4. And so this right here, 9 root 2 over 4 is going to be my simplified answer for the second example. Moving to the final example, once again, we're going to multiply coefficients with coefficients and radicands with radicands. Outside numbers with outside numbers, inside numbers with inside numbers. 5 times 6 is going to give me 30. 11 times the square root, the square root of 11 times the square root of 33 is the square root of 363. Now, before we circle this answer, we must check to see if we can simplify 363. Again, you want to look for strategic numbers. Keeping in mind that I multiplied 11 and 33 to get 363, that may be a helpful place to start. I can say 11 and 33. And then the 33, you might notice, divides the 3 to get 11, so I can split that up, and I'm going to just do it this way because I'm out of space, and I get 3 and 11. So 363 has a perfect square in it of 11. So 11 times 11 is 121, and the square root of 121 is 11. So my answer, and I'll move it down to here now, is going to be 30 times 11, square root of 3. So all I need to do here is multiply 30 times 11, which would give me 330 square root of 3. So when reviewing this topic, you definitely should look back at your algebra studies and look at how you added, subtracted, multiplied, and divided there. And you're really applying the same principles here to radical expressions.